Question 1. Which statement accurately describes how Azure manages the Kubernetes control plane in AKS and its associated cost implications for the user? Option A. The user provisions and pays for all control plane VMs, but Azure manages their patching and upgrades. Option B. Azure fully manages the control plane components, API server, etcd, etc., and the user is not directly billed for these resources. Option C. The user is responsible for managing and upgrading the control plane, but Azure provides monitoring tools. Option D. The control plane components are deployed as containers on user-managed worker nodes, incurring direct VM costs. The correct answer is Azure fully manages the control plane components, API server, etcd, etc., and the user is not directly billed for these resources. Here's the explanation. In AKS, Azure fully manages the Kubernetes control plane components, ensuring their high availability, security, and automatic upgrades. Users are only billed for the worker nodes and associated networking/storage resources, not directly for the control plane itself. Question 2. A network architect is designing an AKS cluster for a large enterprise application where pods need to directly access other resources within the Azure Virtual Network, VNet, without network address translation, NAT, and require a large, flat IP address space for pods. Which networking model is most suitable for this scenario? Option A. Kubernetes. Option B. Azure CNI. Option C. Calico. Option D. Flannel. The correct answer is Azure CNI. Here's the explanation. Azure CNI Container Network Interface assigns each pod a direct IP address from the VNet subnet. This allows pods to communicate directly with other VNet resources without NAT, which is crucial for larger clusters and direct VNet integration. Kubernetes uses NAT and is simpler but less performant for direct VNet integration. Calico and Flannel are open-source CNI plugins, but Azure CNI is Azure's native solution described in the material for direct VNet integration. Question 3. A DevOps team wants to ensure their AKS cluster can automatically adjust its resources to handle fluctuating application demand. They need to scale the number of running application instances, pods, based on CPU utilization, and also add or remove virtual machines, nodes, in the cluster if there are unschedulable pods. Which two autoscaling components should they configure? Option A. Vertical Pod Autoscaler, VPA, and Horizontal Pod Autoscaler, HPA. Option B. Horizontal Pod Autoscaler, HPA, and Cluster Autoscaler. Option C. Cluster Autoscaler and Virtual Node Autoscaler. Option D. Azure Load Balancer and Ingress Controller. The correct answer is Horizontal Pod Autoscaler, HPA, and Cluster Autoscaler. Here's the explanation. The Horizontal Pod Autoscaler, HPA, scales the number of pods in a deployment based on metrics like CPU utilization. The Cluster Autoscaler scales the number of worker nodes in a node pool based on the presence of pending pods that cannot be scheduled due to insufficient resources. Together, they provide comprehensive autoscaling for both application instances and underlying infrastructure. Question 4. A company needs to deploy an Azure function that processes real-time sensor data, requiring low latency and consistent performance, with the ability to connect to resources within a private Azure virtual network. Which Azure Functions hosting plan would best meet these requirements? Option A. Consumption Plan. Option B. Premium Plan. Option C. App Service Plan. Option D. Dedicated Plan. The correct answer is Premium Plan. Here's the explanation. The Premium Plan offers pre-warmed instances to avoid cold starts and provides virtual network connectivity, which are crucial for low latency, real-time workloads requiring private network access. The consumption plan can experience cold starts and lacks VNet integration. The app service plan also offers VNet integration and consistent performance, but doesn't scale dynamically in the same serverless manner and incurs costs even when idle. Question 5. A developer wants to create an Azure function that is automatically executed when a new file is uploaded to Azure Blob Storage, and the function should then save processed data to an Azure Cosmos DB collection. Which two Azure Functions features are most appropriate for simplifying this scenario? Option A, HTTP, trigger and output binding. Option B, timer trigger and input binding. Option C, blob trigger and output binding. Option D, event hub trigger and input binding. The correct answer is blob trigger and output binding. Here's the explanation. A blob trigger will automatically execute the function when a new blob is created in Azure Blob Storage. An output binding can be declaratively configured to write the processed data directly to an Azure Cosmos DB collection, without requiring explicit connection code within the function. Question 6. A solution architect needs to design a serverless workflow that involves a sequence of asynchronous operations, including fan-out/fan-in processing and long-running human interaction with state management. Which Azure Functions extension is specifically designed to handle such complex, stateful orchestrations? Option A, Azure Logic Apps. Option B, Azure Web Jobs. Option C, Durable Functions. Option D, Azure Container Apps. The correct answer is Durable Functions. Here's the explanation. Durable Functions is an extension of Azure Functions that enables the creation of stateful orchestrations in a serverless environment. It supports patterns like function chaining, fan-out/fan-in, and handling long-running processes, including human interaction, with built-in state management. Azure Logic Apps is a low-code workflow service, Azure Web Jobs is an older background task service, and Azure Container Apps is for containerized microservices. Question 7. A network architect is designing a new Azure environment and needs to ensure that a virtual machine, VM, deployed in a subnet can securely access an Azure SQL Database PaaS service without exposing the SQL database to the public internet. Which networking feature should be implemented for the most secure and private connectivity? Option A, Network Security Group, NSG, rules allowing outbound traffic to the SQL database's public IP. Option B, a service endpoint for Azure SQL Database on the VM's subnet. Option C, an Azure private link for the Azure SQL Database connected to the VNet. Option D, a user-defined route, UDR, to direct traffic through an Azure firewall. The correct answer is an Azure private link for the Azure SQL Database connected to the VNet. Here's the explanation. Azure Private Link brings the PaaS service into your VNet via a private IP address, completely removing public internet exposure for that service, offering the highest level of security and privacy. Service endpoints restrict access to authorized VNets, but the service still has a public IP. Question 8. Which of the following statements accurately describes the transitivity of VNet peering? Option A. VNet peering is fully transitive, meaning if VNet A is peered with B and B with C, then A can communicate directly with C. Option B. VNet peering is non-transitive. If VNet A is peered with B and B with C, VNet A cannot communicate directly with VNet C unless explicitly peered. Option C. VNet peering is transitive only if all VNets are in the same Azure region. Option D. VNet peering transitivity depends on whether BGP is enabled on the peered connections. The correct answer is VNet peering is non-transitive. If VNet A is peered with B and B with C, VNet A cannot communicate directly with VNet C unless explicitly peered. Here's the explanation. VNet peering is a non-transitive relationship. This means that if VNet A is peered with VNet B and VNet B is paired with VNet C, VNet A cannot communicate directly with VNet C through VNet B. For A to communicate with C, an explicit peering between A and C would be required. Question 9. When configuring a subnet within an Azure virtual network, why does Azure reserve a certain number of IP addresses, and how does this impact the smallest usable subnet size? Option A. Azure reserves the first two and last two IP addresses for network management, making 30 the smallest usable subnet. Option B. Azure reserves the first four and the last IP addresses for internal use, meaning a 29 subnet is the smallest that provides usable IPs. Option C. Azure reserves only the default gateway IP address, allowing 31 subnets for point-to-point links. Option D. Azure reserves all IP addresses for future services, requiring manual IP assignment for VMs. The correct answer is Azure reserves the first four and the last IP addresses for internal use, meaning a 29 subnet is the smallest that provides usable IPs. Here's the explanation. Azure reserves the first four IP addresses, network address, default gateway, Azure DNS, future use, and the last IP address, broadcast address, in every subnet. Therefore, a 29 subnet, which contains 8 IP addresses, is the smallest subnet that provides at least 3 usable IP addresses for your resources. Thanks for watching. Please subscribe to my channel.